We have these kind of two camps of users, the researchers and the developers. And developers keeps telling us like, hey, I just want one button. I just want like the best model to come out. And then like a lot of the researchers want to kind of, fiddle more with the parameters. And I think we can probably satisfy both for a long time.
You're listening to Gradient Descent, a show about machine learning in the real world. And I'm your host, Lukas Bewald. Today, I'm talking with Peter Welinder, longtime friend and currently VP of Product and Partnerships at OpenAI, running GPT-3 and other things. And before that, research lead at OpenAI, where he was one of Weights and Biases' very first customers. And before that, head of machine learning at Dropbox. And I'm also talking with Boris Dayma, machine learning engineer at Weights and Biases. And we're going to talk about GPT-3 and the recently announced integration that GPT-3 did with Weights and Biases. So this should be a lot of fun. So Peter, the last time we talked, I think you were working on research at OpenAI, and that's most of the time that I've known you. But now we find that you're VP of Product and Partnerships at OpenAI. And I'm kind of curious what that means and what you're doing day to day.
Yeah, sure. What I do today is quite different from when I did research, for sure. For me, doing research has always been about kind of solving the hardest problems that are out there in order to actually have some sort of impact on the world. So I'm kind of personally much more driven by the kind of end goals of research rather than the research itself. It's like really fun to do research, go down and explore things research-wise, but it's always been with some goal at the end of it. And one exciting thing that has happened with GPT-3, like a lot of the things that I did when I started at OpenAI was like I did things on the robotics side, and with robotics, it's still, there's still some gap from the stuff you can do in the lab and what you can do in the real world. And with GPT-3, when we kind of got our first results in GPT-3, it was kind of clear that we had something that we could start applying to kind of real world problems rather than just do cool demos. Like when I worked in robotics, what we got at the end was a really cool demo of a robotic hand solving Rubik's Cube. But it's not like you could start deploying this in everybody's home, and even if it worked robustly enough to do that, I don't know if it's how useful it would be to kind of solve Rubik's Cubes. Very expensive way of doing that. But with GPT-3, like we had a kind of a language model that you can now apply to solve all kinds of different problems, like everything from translation to summarization to things like classification and question and answering and so on. It was a kind of very flexible model. So what we kind of set out to do was to kind of start just seeing if this was good enough of a model to actually solve real world problems. And for me, that's just a really fun area to focus on. It's like when you have this kind of really powerful new technology that has the potential of just changing a lot of things in the way they work. It's all about kind of finding the right problems to go after and then seeing kind of how you build, you take the tools you have in your toolbox to kind of solve those problems. The difference is that what I did as a researcher was very much kind of coming up with the right kind of benchmarks and the right ways to kind of measure progress, where there was a goal that was really far out and you kind of needed to come up with these kind of toy ways of evaluating progress. And now it's like customers telling us like, hey, I'm trying to apply GPT-3 to this use case and it doesn't work, or it's too slow or something like that. And it's like, like those problems are much more concrete. So, my day to day, right now it's much more around kind of building a team that can kind of solve these real world problems with the technology that we have developed at OpenAI.
When you look at GPT-3 versus the other approaches for large language models out there, that kind of seems to be a trend, are there kind of key differences that you notice in how it works? Like, is the take different somehow?
Yeah, that's a great question. I think that what I really like about GPT-3 and the main way in my mind that it is different is that it's just extremely simple. All that GPT-3 does is, so GPT-3 is like, it's a kind of a large language model, big neural network. It's using this kind of transformer architecture that Google introduced a couple of years ago that has been really popular and is basically powering all different language models these days, and it's starting to kind of make its way into other areas like computer vision as well. But the way GPT-3 is kind of set up is it's very simple. It has some context, which basically means it can look at kind of a history of text. So maybe like if you're reading a book, you can look at the page of text or the paragraph of text, and then it's trying to predict the next word. And that's the way the GPT-3 is trained. It's just trained on lots of texts from lots of different sources, mostly from the internet. And it's just trained to kind of over and over again predict, based on some words it's seen, predict the next word. You can start with only like a few words, but like when we train these models today, we train them on the order of like 1,000 or a few thousand words. They can look back at those 1,000 words and then try to predict the next word. So like the setup is super, super simple, and you just train it on these huge data sets of text in order to keep on predicting the next word and get really, really good at that. And I think the surprising thing with GPT-3 was that if you do that, and then you make the model really, really large, so it has a huge capacity of learning, then it gets really good at a bunch of tasks for which you previously needed specialized models. Like if you want to do translation, you would need a specialized kind of translation neural network. Or if you want to do summarization, similarly, you would set up your neural network in a particular way and then train it on only summarization tasks. And what we found with GPT-3 is that you actually get very close to state-of-the-art performance on a number of these benchmarks that measure things like summarization, translation, question answering, and so on, with a model that has just been trained on the internet to not do any of those tasks specifically, but by just being able to kind of reproduce text in a similar way that it has read it.
And so practically, though, how do you apply it to, say, a translation task? Like, how do you take predicting the next word and make it do a translation?
Yeah, that's a great question. So in a lot of those other large language models, like there are certain steps where you would sort of take a piece of text and you would encode it. So you would like create some representation in your neural network, and then you would have sort of a decoder that would take that and then kind of write some sentence. So if you did translation, for example, you would encode that into some sort of representation, and then you would have a separate piece of your neural network that took that representation and tried to output what you wanted. So the input might be like a sentence in German, and the output might be a sentence in English. And it's been trained specifically for that. And for GPT-3, to your question, then what do you do with GPT-3? Like the simplest way you would do it is that you would provide a few examples of what translations might look like in just pure text. You would like write German colon and some sentence in German, and then English colon, some sentence in English. Maybe you could provide only a single one. Then the setup is called like one shot. You could provide a few examples of like basically German colon, English colon examples, and then you would put in like the new sentence that you would want to translate. That's called few shot training, where you have a few examples, and the model would just, by looking at the pattern of what it's now seeing in its context, it can predict, it can produce a translation. So it's like a very simple setup. Like basically, the way I think about telling GPT-3 what to do is a little bit like how you would actually tell a human to do the same thing. Like if I'm writing an email to you saying like, hey, Lukas, I want you to translate some sentences, what I would do is like, hey, I would just ask you, please translate these sentences, and I would like maybe provide a few examples to give you a sense of the tone. Like, do I want a more formal translation, more casual translation, and so on? And you would pick up on the pattern. You would give it then a sentence in German I don't know if you know German, but like you would be able to translate it to English. And it turns out like now with our latest models, like you don't actually even have to provide those examples. You can often just ask the models just as you would ask a human, like, hey, translate this sentence to me, or summarize this piece of text. We just found that that's how people wanted to use the models. We kind of made them more work like that, but like that's how simple it is. You just kind of tell it what you want to do, and it will do its best attempt at just doing it.
So did you make a concerted effort to train the model on multiple languages, or was it mostly English, or where did the corpus come from?
We actually did the opposite. Like we initially, when we trained GPT-3, we made a concerted effort not to train it on other languages than English, because it turns out that even though these models are huge, there's like a trade-off in your data set mix. So if you train it on kind of English, but then lots of other languages, it would just not end up being as good at English tasks. And like ultimately, when we train this, we want to kind of see just generally like how good can it be at more general capabilities? Like we didn't care as much about kind of translation. So whenever we put in like extra languages, like that would just be at a cost of like being good at performing other tasks in English, like question answering and summarization and so on. So, but it turned out like even by explicitly trying to kind of filter out most other languages, probably like a few small percentage points of the data turned out to be in other languages. And even with that, the model is just incredibly good at translation. It's kind of close to state of the art in a lot of translation tasks. I'm a native Swedish speaker, but I've lost my ability to kind of write things in Swedish these days because I never do it. So what I do these days is like I write it in English and I ask GPT-3 to kind of translate it to me, and that's like usually my starting point. You won't get it perfect. I need to fiddle with a few things, but it's kind of surprisingly good. And like the amount of Swedish training data in the model was like really, really small. I think we've been constantly updating our models and making them better and better. So now we are introducing more and more language data as we kind of figured out how to make these trade-offs in more optimized ways. But yeah, like originally, we actually wanted the opposite. We just wanted to be really good at English.
And is it predicting words or is it predicting like one character at a time? How does that work?
Yeah, it's neither of those. It's actually predicting something called tokens, which is like part of words is maybe the way to think about it. For the most kind of common English words, they are captured by a single token. And a token, it's basically what it is it's sort of, I think, our current setup, we have about 50,000 of these tokens, and we map them onto kind of sequences of characters so that it ends up being like, a common word like hi or the ends up being one token. But then if you have a more uncommon word like encyclopedia or something, you're probably going to break it up into 2 or 3 tokens. So it's like word pieces that just makes it easier and more efficient for these language models to consume text. In principle, you can actually do it at the character level as well. It just gets very inefficient, but that's where the field is probably moving. Eventually, it's going to just do it at the character level.
But I would think that might make foreign languages really hard. Like, for example, would Asian languages be impossible then if they have far more tokens? Or I guess maybe you could argue they've sort of done the tokenization for you by having a larger number of characters that encode like a bigger chunk of meaning.
Yeah, it is definitely the case that the way you train your tokenizer will have an impact on like the performance of different languages. So, and usually those two things are trained in 2 different steps. You would train your tokenizer on some corpus of data, and then you would separately train your models with that tokenizer on some other data sets. And in order to kind of get your models really good at different languages, you need to train the tokenizer as well over multiple languages. And it's kind of more expensive to use other languages because they end up like, a German word just ends up being more tokens because we've trained on much less of it, while like English is very efficient where a lot of words are a single token. So while it's like, so it makes it both a little bit worse at other languages and more expensive.
I see. Could I translate something into Japanese? Would that even be possible for GPT-3?
Oh yeah. One comment I remember was like a Japanese users of ours, they really like to use GPT-3 to translate technical documentation between English and Japanese because they found that GPT-3 was much better at this translation of technical documentation than Google Translate. This was like, a year back, so it's possible that Google Translate is better now, but probably just a chance thing based on like the data sets that we had. I mean, the really cool thing actually with the translation capabilities of GPT-3 is that we haven't really trained the model on explicit pairs of input and output, kind of translated pieces of text, like what you usually call in the like aligned pieces of text. It's just like, it's seen a lot of Japanese. It's seen a lot of, well, not super much. It's seen a bunch of Japanese, but a whole like ton of English. And somehow, through learning how to predict the next kind of word, there's been a lot, like enough of little kind of pieces of text, blog posts or whatever, there, where like the author is switching between Japanese and English and maybe doing like some translation on some sentences where it kind of found the mapping and then somehow has a representation that's good enough then to kind of generalize to arbitrary translation tasks. For me, that's just like kind of magical, that it's just by reading lots of English text, lots of Japanese text, and then maybe like accidentally finding a few kind of aligned pairs in all of the data, it's able to do that kind of translation. That's pretty crazy to me.
That is really amazing. Is its performance kind of tangibly different than earlier versions of GPT? Like, was there something that happened in GPT-3 where OpenAI thought, okay, we can like use this for real world commercial applications? Was it sort of like a performance level that it needed to get above?
Yeah, definitely. I think the big difference between like GPT-2 and GPT-3 was really it was trained on more data and it was a bigger model, like by 2 orders of magnitude. I think the original GPT-2 was about 1.5 billion parameters, and GPT-3, the biggest model, was 175 billion parameters. So it went up by like 2 orders of magnitude. And since it was a much bigger model, it also needed more data. So the surprising thing is that that's sort of what it took to kind of go from feeling fairly kind of dumb to interact with. Like GPT-2 was kind of cool, but it also felt kind of incredibly stupid most of the time. And I think with GPT-3, it went to being like, sometimes just surprisingly good. Like, don't get me wrong, like GPT-3 does a lot of silly mistakes still, but it does the right thing probably like 30 to 50% of the time on some tasks, and sometimes even better than that. So it's sort of like suddenly, before you would need to kind of sample and try out tasks, and like maybe in once every kind of 20 or something, you would see something, oh, this looks pretty good. And with GPT-3, it kind of started happening like every third time or every half time, like second time or every fifth time. And you're like, oh my God, this is actually for things like summarizing text, for example. Like one example we have is summarizing a piece of text in the style of a second grader. And it's just like incredible how the model is able to kind of simplify words, get the gist of a piece of text and so on. And again, it's not perfect, but it's just really good. And obviously there's a lot of academic benchmarks. You can then run these models and you can see it kind of just getting much better on all those academic benchmarks. But it was a whole different feel to it when you wanted to prototype something. The difference is that now it's just easy to get something that works pretty well. And that's sort of why we decided, like, hey, this now it seems useful. GPT-2 didn't seem kind of really useful to the same extent, but GPT-3, for all these tasks, we felt like, okay, it's close enough to kind of state of the art. If you have like a specialized model or whatever, a clever programmer should be able to apply it to whatever task they have, and that was what we set out to validate with the API.
What are some of the use cases that you feel really proud of where it really works? Are there any that you could point us to where we could go interact with it in a commercial setting somewhere?
Yeah, sure. I think some of the areas where we kind of were most kind of surprised were copywriting and question and answering, and generally creative writing. For copywriting, what happened there was that there was a number of companies that started building on top of our platform. Some of these companies are like, I think Copysmith was one of the first ones, CopyAI. There's also Jarvis, I think, recently changed their name to a different name, and a number of other of these companies. And what they did was really clever, because they realized that, as I said, like when you're using GPT-3 to kind of do some task, it's not perfect. So every now and then you would get something that doesn't really make sense. But if you're doing copywriting tasks, like what if like you want to write, say, some engaging product description based on some attributes of a product, like a shoe, maybe like the type of sole, the color, some other attributes of the shoe, and you want to kind of write something really engaging about that, then the problem that you as a human face is that you get into some kind of writer's block, like where do I even start? And what these companies started doing is they took GPT-3 and they used it to kind of generate a few kind of starting points or a few variations of how you could write product descriptions. And then what you find is, like, more often than not, if you generate like 5 of those examples, like one of them would look really good, and you can kind of use that as your starting point. Maybe just take it as it is, or you make some small tweaks to it. It's a way to really almost like aid in human creativity, and I think that's just so cool. It was at like writers who would tell us like, hey, I've been trying to write this book for like half a year now. I just keep on getting stuck in writer's block. And then I started using your playground for GPT-3, and now it took me 2 weeks to churn out the whole book. It's sort of, when you get stuck, it can kind of create an interesting storyline. When you start as a creative writer, you start exploring that. Like, that's okay. I wouldn't have thought of this character going down in that direction. but let's explore that. And then it becomes a much more fun, engaging process. So it's almost like, as a human, now you have like a brainstorming partner that you can apply to all these different tasks. And I think what I found was really cool is to kind of see a number of companies kind of really leveraging that and creating kind of new experience that just you couldn't do before. So I think that one is really exciting. I think question answering is also really cool, but this one was like quite unexpected. I don't think we would have predicted that one being such a big use case.
It seems like one of the advantages of GPT-3 is that it works right out of the box. But I could also imagine for some teams, there might be a concern about what do you do if something goes wrong. I guess I'm curious, do you typically work with ML teams inside of companies, or is it more like engineers that view the benefit here is that they don't have to figure out how machine learning works to kind of get the benefit of natural language processing? Or do you tend to like integrate this with ML teams into like a kind of bigger ML workflow?
Yeah, that's a good question. It's a bit of a mix, I would say. We've had multiple machine learning teams who kind of, already had their own models that, they would have downloaded the models online and so on, and they would have like kind of adapted them for their tasks. And then, they find our API and start doing the same thing using our API. And it just turns out that you can get much better performance from our models, like just because there isn't like an open source version of the biggest models that we have, the best models. And so for a lot of tasks, that's kind of what works the best. But I think probably the majority of our customers are more in the other camp of just really smart developers. And when I say developers, it's a pretty broad group. Like we see everything from like programmers, engineers to like designers, PMs. A number of people have told us that the OpenAI API was sort of what got them into programming, because they got really good results from just in our playground where you can interact with our models, and they kind of got ideas and they started to learn how to code, and they start connected with no code tools like Bubble.io and stuff like that. It's kind of really lowered that barrier. Like you don't have to become a machine learning expert to get really good results out of these models. You just kind of have to be kind of good at iterating and figure out how to kind of write the instructions to the model. It's a little bit like, it's sort of everybody becomes a manager. You have to give really good instruction to your employee if you want them to kind of do the task as you want it to be done. And it's very similar with these models. Like if you underspecify your tasks, you're going to get very high variance in the outputs. But if you get really good at specifying and providing a few examples, then you get really good results. And that's not a machine learning skill. That's like almost more of a kind of task specification, like management skill. And so like I feel like a lot of people can kind of pick that up really, really quickly. I think that I've been really excited about that, just seeing so many people get access to these models that just seem like you had to have a PhD in machine learning to work with before.
I feel like I've heard of people talk about a new role called prompt engineer that might be related to this, of figuring out how to prompt GPT-3 to get it to do what you want it to do.
So this one is interesting because we early on when we had the first version of the API, we had a really smart guy who is a world-renowned author, but also kind of a programmer, Andrew Main. He was one of the early users of the API, and he kind of got the internal name of like the prompt whisperer, he or like GPT-3 whisperer. He kind of really knew how to craft the prompts to kind of get the best results. And since it's been trained on the internet, you kind of need to put your mind in like how would a text on the internet kind of start. So if you wanted to kind of a really good recipe, you had to kind of start writing in the tone of like a recipe book or a food blog post or something like that. It's not like you could just ask the model to do what you wanted it to do. So I think initially, there was a big piece to that. Like you really had to be good at understanding kind of the intricacies of GPT-3 and design really good prompts. Over the past 1.5 years since we launched, we saw people struggling with this a lot. So we developed a new set of models. So we called Instruct GPT, which actually just like last week became like the default in our API. And the reason we call it Instruct GPT is because you just provide instructions. So like I would say like prompt design is a little bit less of a thing now. Like you could just tell the model what you wanted to do and provide a few examples. There's still a little thing about like the formatting might impact like how you provide your examples and so on. Not like GPT-3 is like super robust to that, but like sometimes it does matter a little bit. Some tweaking matters, but I would say like it's less of a thing now than it was like a year ago. And my hope is that it becomes less and less of a thing, and it becomes much more almost interactive.
And you've also launched the ability to fine tune the models. What's the thinking there, and where is that useful?
The surprising thing with GPT-3 was that you got really good results, zero shot, where you only provided like an example, no example, just instructions of like, hey, translate this sentence from German to English. Or you provided few shot examples where you provide a few pairs of German and English. And with just a few shot examples, you could get like just surprisingly good results. But what that meant in practice is that, the accuracies are very task dependent, but like for some tasks, maybe 30% of the time you got an output that was kind of acceptable to kind of put in a product. And then for other tasks that were more simple, you'll get it like maybe 70% of the time. And so when it's like not good every time, you have to be very clever in the way you kind of expose it in your product. And that's why, like, for example, it worked well for a lot of those copywriting companies, because you could just provide a few examples and you kind of knew that at least one of them would be good. And that's all the user needs. But with fine-tuning, what you can do is basically you can customize your model. So you can provide more examples of the inputs and outputs you want to do. If you want to do kind of translation, or if you want to kind of summarize articles, you can provide like a few hundred examples of articles that have then human written summaries. And you can actually update GPT-3 to do much better at that task. Like you couldn't put all those examples in your prompt. The prompt has like limited space, but like with fine-tuning, you're like working these examples into the connections of this neural network, into the weights of the neural network. And so in some way you have like an infinite prompt. Like you can provide as many examples you want. Obviously, the more examples, the longer it would take to fine-tune, and the more costly it would be. But fine-tuning is basically that concept of taking a bunch of input and output examples and kind of working them into the model and getting kind of a new version of the model out that's really good at that task for which you provided examples. It turns out like with only like a few hundred examples, or like around 100 examples, you can kind of get significant boosts in accuracy. So we had a number of customers that have used it, like keeper tax. They're doing these, they're like analyzing transactions to find these tax write-offs and stuff like that. And so what they're doing is like they're extracting the relevant pieces of text, they're classifying and so on. And so they fine-tune models and got much, much better results with fine-tuned models, for example. And we've seen that over and over again with our customers. They can get really good results that can often be good enough for a prototype, but then in order to get it to kind of high enough accuracy to put it in production, which is usually like more than 90% or 95 or 99%, fine-tuning on some data sets that they have or they put together kind of gets them all the way. So that kind of enabled many more applications than you could do before. So we just made it very simple to do this kind of fine tuning.
Cool. And I have to ask you about the weights and biases integration. I mean, we're so excited about it. I don't know if people listening would know that you used weights and biases from the very early days and provided a ton of incredibly useful feedback that's in the product. But I was curious how you thought about how that integration might be useful for users of GPT-3.
So I think that this is the background of my usage of weights and biases. Like I was like one of the first users, and it's just like it just improved my research workflow so much that I'm a big kind of weights and biases spokesperson now. Like I just like it's like basically what it does, right, is that it allows you to kind of track your experiments in a really nice way. As you're training your models, you can kind of get all the stats. Anybody who's kind of trained machine learning models knows that you kind of have to look at a bunch of curves as you're kind of doing your training to make sure that the models are kind of learning in the way that you want. And a lot of like the work you do as a machine learning engineer is to kind of do that sort of iteration on your models and seeing if you can improve your results. And a lot of that is looking at those learning graphs and so on. And it's really good because like weights and biases provides you with this kind of history of the experiments you run. They let you compare experiments and let you kind of track your progress and share it with your team and so on. And what we did is basically making integration so that as you're fine-tuning your models, your GPT models via our API, all your experiments, all your training runs show up in the weights and biases interface. So you get that same convenience, but now for things that are training in our clusters and so on. So you can kind of see as our fine-tuning process is happening, as the model is updating its weights based on each new iteration of going through the data set, you can kind of see your metrics and so on improve. And you can also we provide a number of different parameters, so it lets you kind of iterate and try out different parameters and so on and see your progress. So yeah, it's just much more delightful to train your models that way, to kind of have that place where you can go and look at your results in an ongoing way. So that was a super exciting integration for us. Kind of lets you kind of keep track of all your fine tunes in a much better way than we have a command line interface. It's not at all as pretty as the weights and biases way of tracking things. So,
Boris, you actually said you did the integration, and you said it was one line. Is that right? I mean, my question for you is more, how you thought about how it might be used. But I'm curious, was it really a one-line integration?
I mean, there's a few more in the code, but the way for the user is just to type a line, to type OpenAI 1DB sync, and he can automatically sync all his runs to a dashboard. The idea was that there's a lot of people who use the API that are not ML engineers. So you don't want them to have to learn, okay, what am I supposed to log, or how do I take care of a data set? And the OpenAI API was so convenient. When you want to train a model, you just pass a file that is your data set, and it cleans up the data set, and then you pass a new command and it fine-tunes everything. So it was a bit the idea of keeping the same simplicity. So you will just type that one command, and then, all the magic happens behind the scene, and you have all your visuals, and you can compare your models and see is it worth giving more training samples? How much did my model improve from that? What is the effect of tweaking that little parameter here? And what data set did I have when I trained that model? So it's trying to make it as easy as possible for users to benefit from all the features when they don't necessarily know weights and biases initially.
And I guess for both of you, what are the parameters that you can actually tweak? Because the way you've described it, it sounds to me like there might not be any parameters. How do parameters get involved here?
So before I answer that question, one thing that Boris said that really stands out to me, by the way, why I really like this integration generally was that there is this concept of just making these kind of advanced things very simple. And I think I still remember when, Lukas, you, Sean, and Chris kind of did the first weights and biases demo, and it was basically just import 1B and it was to kind of just start logging the experiment. I think that philosophy of just making it super simple to get going is something we have tried to also do in our API, where it's you import OpenAI and then a single API call, a single line of Python or JavaScript kind of gets you to use GPT-3 and start creating kind of completions and stuff. I really like that kind of that simplicity, and that's what we try to do with this integration. But to your question about the kind of parameters, we've tried to make this quite simple in our API. We try to kind of make the defaults very, very good, and generally you can get really good results with fine-tuning without fiddling much with our parameters at all. But some kind of makes more of a difference. You can set, for example, the learning rate. That's how much you're updating the weights with each learning step. You can set things like how many passes you want to go through the data. It turns out if you go through the data too many times, then you're going to overfit on your data set. So these GPT-3 models being really big, you often only need on the order of 2 to 5 iterations through your data to get really good results. And if you go further than that, you sometimes overfit. And there are more advanced parameters as well. But I cannot be playing a bit with the number of epochs you want to train it for and the learning rate. That gets you 90% of the way there. And if you start filling with other parameters, it's not going to give you that much more.
Was part of the thinking of leaving the parameters in to just give the person tweaking it the joy of messing with parameters?
I think, honestly, I would love it if it was completely automatic. That said, we do have a number of more research-oriented customers who really do like the fiddling. So I think it would be hard for us to remove it. But as I said, we have these kind of two camps of users, the researchers and the developers. And developers keep telling us hey, I just want one button. I just want the best model to come out. And then a lot of the researchers want to kind of, fiddle more with the parameters. And I think We can probably satisfy both for a long time.
Boris, I don't know which category you put yourself in, because you make some amazing, beautiful demos, and you also, I know that you love to tweak parameters. I'm curious your experience playing with the GPT-3 model.
I definitely like having the good default, because initially you don't really know what you should change. And let's say you would choose the wrong parameter and nothing works, it wouldn't be a nice experience. So I like that if you don't choose anything, it's already going to be pretty good. Then I really like to tweak the parameters to see, okay, what would be the effect, and try to play with intrusion. And in addition to the parameters that Peter mentioned, there's two that interest me a lot too. You can decide which model you fine tune. So there's a model of different size. And like if you use a larger model, maybe your API is going to be a bit slower, but your accuracy will be better. And maybe sometimes you don't need it, maybe sometimes you need it. So I like to see the effect of which model I use. And I like to also see the effect of how many training samples can I give. Like if I give only 20 samples versus giving 100 or 200, because then it gives you an idea on how much my model is going to be better as I develop a larger data set. So those are kind of parameters I like to play with and see what are the predictions based on these.
Yeah, that last one I think is like, it's actually super important. I think it's like one of the most kind of common advice we kind of give people over and over again. Is like start with a small set of examples, then double it and see how much of a different like improvement you get. Usually, if you double your amount of training data, then you're gonna see some linear improvement in your error rate. So if you have like 10% error rate or something, then you double your training data, you're going to get down to maybe like 8% error rate. And then you double it again, you get down to 6% error rate. And so on. Like if you can kind of start seeing that trend, then you can suddenly get a sense of like how much would it actually cost me in terms of like labeling more data and so on to get the result that I want and so on. So it's a very powerful thing to do.
Are the results of training these models reproducible? Like how much variability is there each time you fine tune it? Would you get the same model if you fine-tuned on the same data two different times?
I think so. In principle, you can set it up to be quite reproducible. Like if you basically train it on the same data, like you keep like basically what you want to do when you train is on each training iteration, you have a batch of data, like a number of examples. So you can actually in our API you can set the batch size, how many examples per update you want, and I think like it defaults to 32 or something like that. And when you do that, you also want to shuffle the data. So you want to take a random sample of your training data. As long as you kind of keep those randomizations consistent between your training runs, you're essentially going to get the same model at the end of it. It's going to be fairly reproducible. The only caveat is that in practice, like this is true even for inference, like we have a parameter called temperature where you can set the variability in the output. Higher temperature, the more variability. And even if you put it at 0, there's no real guarantee that you're going to get completely deterministic output, because there's enough like noise and little weirdness with like floating point arithmetic and so on in these GPUs with these really big models that it's very hard to guarantee complete determinism. So we get people asking about that a lot, and the answer is always like, well, unfortunately, we cannot provide that, but you can get something that's fairly close to it. But you should just make your experiment robust enough that you don't really care too much about the determinism.
I would think operationally, having everyone have their own fine-tuned model would be much more of an infrastructure challenge than everybody using the API that hits the same model. Has that been a big undertaking to allow that to happen? Like, do you have to like swap in and out the different models as people start to use them?
Yeah, no, for sure. Like this is when we started out, the way we did fine tuning was basically, in some way you almost kind of rented a set of GPUs where the models ran on. And even like for some of the absolutely earliest fine tuning customers, we essentially charged them by GPU hour to some extent, like per hour, how much they were using the models. And, even from the very beginning, like I think like within 6 months after launching the API, we had a few select customers that had fine tuned models and stuff like that. And that's sort of the way it worked. The problem with that is like, if you're like trying something new, GPU hours are expensive. So you don't want to really pay for to reserve a GPU for like even a fraction of an hour. It just adds up really, really quickly. So we just set a goal of saying like, well, as soon as you have fine-tuned your model, you should immediately be able to just use that model, and you should just have to pay for basically the tokens that go into it at inference time, like whatever you put in your prompt. And so that was definitely a huge engineering challenge, kind of make that experience really great. Like you just kick off your fine-tune, when it's done, you now get the fine-tune model name out, and now you can use that model in the API to just get a result immediately. And you're not going to be charged by hour or whatever. You're just going to be charged the same way you're going to be charged for the API. And so that was really tricky. We have like an amazing engineering team at OpenAI has kind of really figured out, a lot of tricks around balancing where these models end up and caching them in the right way and so on to create a great experience around that.
I'm curious if you fine-tune the entire model or you fine-tune just part of it to make it more efficient.
Yeah, you can imagine like there's just lots of tricks that we're using to make this happen, but we're constantly kind of trying to figure out new ways of doing it where like there are challenges with if you want to fine-tune a whole 75 billion parameter model, it can get really expensive and hard and so on, and there are tricks you can do to kind of make it much faster.
Do you feel like the thing between you and everyone using GPT-3 for natural language tasks is more quality and performance of the model itself, or is it something else? Is it something about like integration or monitoring production or something like that?
I think definitely the key things we focused on when we built the API was what matters the most is really the capability of the models. And then like number two is like you need to have fast inference. Like before we created our API, like for large language models, nobody cared about inference. Like everybody cared just how quickly can you train them, because that's what mattered, so you can get your benchmarks result at the end of the day. So we did just a ton of engineering to make inference super, super fast. Like I remember like over the course of the first few months of us getting the first prototype of the API to customers starting to use it, we increased the inference speed like 200-fold or something like that. It was like lots of effort that was done to make that super fast. And then the third thing is like things around safety-oriented things. Like, one of the reasons we invested in these Instruct GPT models is that we saw that sometimes you can get surprising outputs of models that you don't expect. Like, for example, you might write a very innocent sentence and it might turn very dark for some reason, or you might get some kind of more biased outputs in different ways. With our instruct-oriented models, by default, they behave in a much more expected way, but you can also specify the behavior in a much better way. So I think it turns out like when safety and capability kind of comes hand in hand, it's like it just becomes a better product when you can control it better. Those are definitely the things we have focused on, and I think we're doing much better on than alternatives that are out there. But there's also the third thing that we have kind of put a lot of focus on is just like making it really simple to use. The fact that you don't have to load up models, that you can just call a fine-tuned model that is just a single line of Python to kind of to call the API. Like that's also been really central to us. It's like just we want this to be easy to use by everyone.
Awesome. Well, thank you very much. It's really nice to talk to you, and congratulations on making such a successful product.
Thank you.
If you're enjoying these interviews and you want to learn more, please click on the link to the show notes in the description, where you can find links to all the papers that are mentioned, supplemental material, and a transcription that we worked really hard to produce. So check it out.